Welcome to watch ZW3D CAM training video. In this video, we will learn about the basic verification ways in ZW3D CAM module. As we all know, safety plays an important role in CNC machining. Before we put the NC code to real machine, we need to check the toolpath and ensure the safety. There are three ways to do the verification: verify, solid verify, and full machine simulation. Then what's the differences among them? Verify is the very basic way, which is to check the tool location on the part, whether it is safe to engage or leave. Then we can optimize the toolpath. Meanwhile, we can verify whether the output NC code is correct or not by comparing the coordinates shown in the verify window step by step. Solid verify is to simulate the cut process on the stock and will show the rest material by a visual way. So it requires stock and can generate the rest material as the stock to take part in the calculation of the other operation or simulation. Normally these two ways can assure the machining safety. But for the complicated case, especially for more than 3 axes, like 5 axis, it is better that we can do the full machine simulation. We build the machine structure and simulate the movement of machine and workpiece to check whether there is any safety risk. Full machine simulation is used for verifying the NC code. In this video, we will just introduce first 2 ways, and the full machine simulation will be introduced in another video. Let's check the verify first. We also call it wireframe verify. As we introduced at the very beginning, verify is to check the tool location and also the coordinate and speed information. We can enter verify window by right-clicking any operation. Just make sure it is not hidden. Or we can just find verify button in the operation parameters window directly. All the settings for verify includes 3 parts: play control panel, frame and tool display control, and toolpath display setting. For the play control panel, we can play forward or backward. It supports to play automatically or play it manually step by step. We can set the play speed, and the max value is 10, which is the same as fast play. Besides, we can also put the tool on the location we want to check whether it is safe manually. In the data display area, we can check the feed speed values and coordinates according to the specified frame. Here is a note: when you adjust the replay speed, you need to click the workspace to make it take effect. Then you can click play button to start it with this new speed. Next is about the frame and tool display. As you can see, we can specify the frame by world, which is the default frame, or toolpath, which is the frame set inside each operation or any custom frame. The coordinate shown in the data area depends on this setting. By checking the coordinates, we can see clearly the movement, and also we can use it to verify whether the output NC file is correct or not. Just make sure the frame should be set the same as the toolpath workspace. We can also set the tool color and display mode as shade or wireframe, or even we can choose display the tool holder to see whether there is any clash risk. In final, we can set the toolpath display. It is very clear that we can turn off some toolpath sections display. For the toolpath display mode, there are 5 modes. We can check one by one. Default, which will show the whole toolpath according to the setting. Current motion, it is to show the toolpath in group. There are 2 groups. One is the cut, which includes the cut, slot cut, slowdown. Another is link, including the rapid, engage, retract, plunge, step over, and transversal. It will show the current connected group toolpath. Absolute Z height is very clear, which shows the toolpath within the absolute Z range according to the specified frame. Like the image shown here, we show the toolpath start from Z50 to Z-10. While the relative Z height is taking the clearance plane as the Z0, we can check it inside the software a little later. The last mode is previous/next location, which shows the toolpath according to the specified previous next location number. Let's just go to ZW3D to check directly. Right-click any visible operation. Click Verify to load the Verify window. Or we can double-click the operation to enter the operation parameters window. Click the Verify button. If the toolpath is hidden, then it will pop up a message in the output window. We can play step by step, play forward or backward. Move to the end or move to the start. Let's check the normal play speed and fast play speed. Then let's modify the speed value as 10 and play. It seems no change. Then we click the workspace to make it work and play again, much faster. Go ahead, let's check the frame. Here it is a turning model, so we need to set it as toolpath or MCS to check the coordinates. We find that the X and Z value changes when verify. If we go to the output setting, we can find there is a toolpath space, and we can set it as machine, which is the world frame, local, which means the frame set in the toolpath, and the custom frame. Here we choose MCS. Output the NC, then let's check the coordinates by verify. It seems the X and Z value is different from NC. This is because we are still using the default world frame. Let's change to MCS. Now the X value in NC is double of X value shown in the verify, which is diameter programming for this machine. It is correct. Next, let's check the tool display and path display. Set the tool display color, mode, and check whether display the tool holder or not. Let's check the final one. We can show all paths or some sections. Like here, we can hide the rapid and retract. Besides, we can choose the display mode. Default is to show all. Current motion is showing the connected toolpath in the same group. Like here, the rapid/engage and plunge are in the same group. Then slot cut. And then step over. Let's check the absolute Z height. We can check the Z value of start and end toolpath based on the toolpath frame. Set top Z50 and bottom Z-8. It will show all toolpath. If we change the bottom Z to -5, it will not show the path below Z-5. If we set it as relative Z height, the Z0 is the clearance plane of current frame. And it will show the toolpath from toolpath between the top Z and bottom Z. Like here, we set 0 and -55. The final one is to set the range by the location number. Finally, let's check one use scenario of the verify. In this case, normally, we use ramp cut to machine these narrow slots. Let's check whether the lead in and lead out is safe. The tool is too close to the side face, so it is not safe. We need to adjust the lead in and lead out. Now it is safe. We can copy to retract. We just checked the toolpath by verify. Before we output the NC code and transfer to the CNC machine, we need to use solid verify to check the cut process and final result. In short, solid verify is to simulate the cut process and check the rest material. During the process, we can detect the clash automatically, and we can adjust the toolpath based on the information. The same as verify, we can find the solid verify by two ways. One is from right-click menu, and another is from the operation parameters window. All the settings for solid verify also include three parts: play control panel, simulation options, and verify file data. In solid verify, we can select multiple operations and play it step by step or automatically. But we cannot play backward. To adjust the solid verify speed, we can slow down by setting the motion delay, or we can speed it up by dragging the update interval bar. Another two useful buttons are rapid to end of current operation and rapid to end. Just check the final result for current operation or for all selected operations. We can go to show path data to check the detailed data like speed, feed and coordinate values, which is using the MCS frame accordingly when play step by step. We can also change the stock. There are three ways to set. We can use the stock that we created in the setup, or we can use the workpiece that saved during the solid verify, or even we can read the outside STL file. Besides that, we can set the simulation options to control the display, analyze the result, and also save the result for later use. First is about display tab. We can set the component's transparency so it can be seen clearly during the cut process. To make it work, we need to set the render mode as hybrid in the render tab and click apply button. In the analysis tab, we can set the tolerance bands and click visual to get the result, and click again to cancel the effect. We can also click gouges to show the overcut range and excess to show the left material that we need to remove. After we finish the solid verify, we can save the result as a workpiece or an independent stock object. Just click Apply in Stock tab to save it or update the workpiece. It will use the operation name by default. If we click Use the rest as stock in STL tab, it will be shown in the setup as a stock class. We can specify it in the operation feature, which is for rest roughing, to take part in the toolpath calculation. Generally, if we just want it to be used for later simulation only, we can just choose to save it as workpiece. But if we want it to be in the toolpath calculation, then we need to save it as a stock. Finally, ZW3D not just can verify the toolpath created in ZW3D, it also can verify the CL or NC file directly. As long as we have the model file, then we can just create an active CAM plan and set a stock, set the machine, and insert any operation. Calculate the toolpath, then we can run the solid verify to load the CL or NC file to simulate the cut process and check the result. Okay, let's just go to software to check it directly. First, we can find the solid verify by right-click menu. You can right-click the operations node, or select some operations and right-click. Or you can go to the solid verify from operation parameters window. Here is the operation list, and we set verify the active only. Play it automatically. Play it step by step. Rapid to the end of current operation. Or we can untick the verify active only and click rapid to end to get the final result. Reset back to the start. If we want to slow the play speed, drag the motion delay bar. Or we can speed up the regen by update interval bar. Normally, we will tick the clash stop to check the clash if any. We can also skip the suppressed operations. From the right-click menu, we can suppress or unsuppress the operation. Or we can choose stock move instead of tool move. If we play step by step, we can also check the coordinate information. Now let's check the simulation options. Set stock transparency as 50 and set the render mode as hybrid. Click apply. We can see the stock is displayed transparently. As we can see, the cut load is a little much for the final cut in the finish turn, so we can go to adjust the rough turn lead out and solid verify again. It is okay now. Next tab is Analysis, which we can check the rest material visually. In this case, we will learn about the stock and STL tab in the simulation options. As we can see here, we can use the ref operation for the rest roughing, and we also can use the rest stock for rest roughing. Let's solid verify the first roughing operation. We can just click rapid to end to get the final result. Go to Options and click Stock tab. Click Apply. It will use the final operation name as the workpiece default name. When we solid verify the second operation, we can set the workpiece as the stock. No need to solid verify the first operation again. After rapid to end, we get the result, and this time we want it to be used in next rest roughing operation. So we go to STL tab and give a name after second rough. Click Use the rest as stock. It is shown in Geometry node. And we can add it in the third rough offset operation and calculate. Finally, let's just check a case to see how the solid verify can help us detect the clash and the rest material. Let's just run solid verify. and we find that there is a clash detected. And it stops in the third operation. Then we can solid verify the first two operations and save the workpiece. And then solid verify the third one. Modify the stock as the saved workpiece. Start verify. We can find the engage causes the clash. So we go to adjust the step over to avoid this island. After adjustment, solid verify the first two operations again. And update the workpiece. Then solid verify the third one. Now there is no clash. Finally, let's check the verify file data. If we just have the model and the NC file, we can do the solid verify too. Open the model, create an active CAM plan. Add stock. Create any operation and calculate. Set the machine. Then solid verify. And load the NC file. Play to check the process and final result. Done. That's all for this video. Thank you for watching.